Imagine a spacecraft, braving the fiery inferno of the sun, a place where temperatures soar to millions of degrees, and the environment is nothing short of hostile. It sounds like science fiction, doesn't it? Yet this is not a scene from a futuristic movie, but this is the reality of NASA's Parker Solar Probe, a mission that is as ambitious as it is groundbreaking. This daring mission is pushing the boundaries of space exploration, venturing into uncharted territories, venturing closer to the sun than any spacecraft before. It's a journey that brings us face to face with our star. The sun, our very own star, holds many mysteries, mysteries that have puzzled scientists for centuries. It's a giant ball of hot gas, a dynamic and ever-changing entity, a churning inferno that emits light and heat essential for life on Earth. Without it, our planet would be a frozen wasteland. But the sun also has a volatile side, a side that can be both awe-inspiring and terrifying. It can unleash powerful bursts of energy, known as solar flares, that can travel across the solar system, that can disrupt our satellites and even our power grids. These solar tantrums can have profound effects on our technology and daily lives. To understand these solar tantrums and unlock the sun's secrets, we need to get up close and personal. We need to study the sun in ways we never have before. That's where the Parker Solar Probe comes in. This mission is designed to withstand the sun's extreme conditions. This groundbreaking mission is providing us with an unprecedented view of the sun, capturing data that was once beyond our reach, helping us to unravel its mysteries and understand its profound influence on our solar system. Every piece of data brings us closer to understanding our place in the cosmos. The Parker Solar Probe is not just a feat of engineering, it's a marvel of human ingenuity and determination. It's a testament to human curiosity, our relentless pursuit of knowledge, our insatiable thirst to explore the unknown, and our desire to push the boundaries of what is possible, and our desire to comprehend the celestial forces that shape our universe. The Parker Solar Probe is a shining example of what we can achieve when we dare to dream big. Why are we so interested in the sun? This giant ball of gas burning brightly in the sky has fascinated humanity for millennia. From ancient civilizations worshipping it as a deity to modern scientists studying its every move, the sun has always been a source of wonder and mystery. Well, it's not just because it keeps us warm. The sun is essential for life on Earth, providing the energy that drives our climate and weather systems. Without it, our planet would be a frozen wasteland. The sun is the powerhouse of our solar system. It generates energy through nuclear fusion, converting hydrogen into helium in its core. This process releases an immense amount of energy which radiates out into space. It drives the solar wind, a constant stream of charged particles that flows from the sun's outer atmosphere, the corona. This wind travels through space, carrying with it the sun's magnetic field. This solar wind affects everything in its path, from the planets to the farthest reaches of the solar system. It shapes planetary atmospheres, influences space weather, and even affects the behavior of comets. It can disrupt satellites, create stunning auroras, and even influence the climate here on Earth. The interaction between the solar wind and Earth's magnetic field can cause geomagnetic storms, which can have significant impacts on our technology and infrastructure. The Parker Solar Probe is on a mission to understand how the solar wind is generated and accelerated. Launched in 2018, this spacecraft is designed to withstand the extreme conditions near the sun. By flying closer to the sun than ever before, the probe can sample the solar wind directly. It collects data on the particles and magnetic fields, providing unprecedented insights into the dynamics of the solar wind. It's like sending a weather balloon into the eye of a hurricane to understand how it works. The closer we get, the more we can learn about the processes driving these powerful phenomena. The probe is also investigating the sun's corona. This outer layer of the sun's atmosphere is a region of intense heat and activity. This outer layer of the sun's atmosphere is much hotter than the sun's surface. Temperatures in the corona can reach millions of degrees while the surface is only about 5,500 degrees Celsius. This is one of the biggest mysteries in solar physics. Scientists are trying to understand why the corona is so much hotter than the surface, a phenomenon that defies our current understanding of physics. It's like water boiling faster the farther you are from the stove. This counterintuitive situation has puzzled researchers for decades, and solving it could unlock new insights into the behavior of stars and the fundamental laws of physics. The Parker Solar Probe is a marvel of engineering. Imagine flying a spacecraft through a region where temperatures reach millions of degrees. That's exactly what the Parker Solar Probe is doing. To withstand the sun's intense heat and radiation, the probe is equipped with a revolutionary heat shield. This shield is made of a special carbon composite material. It's so effective that even though the spacecraft is facing temperatures hot enough to melt steel, the instruments behind the shield remain at a comfortable room temperature. The probe also has a sophisticated cooling system. This system uses a circulating fluid to dissipate heat away from the instruments. It's like having a miniature radiator in space. On December 24, 2024, the Parker Solar Probe made history. It achieved the closest ever approach to the Sun by a human-made object. The probe came within a mere 3.8 million miles of the Sun's surface. That's closer than Mercury, the closest planet to the Sun. And the probe was traveling at an astonishing speed, 430,000 miles per hour. That's fast enough to travel from New York to Los Angeles in less than a minute. At this incredible speed and proximity, the probe is providing us with the most detailed view of the Sun's atmosphere ever captured. This close approach is a major milestone for the mission. It's a testament to the ingenuity of the engineers and scientists who designed and built this incredible spacecraft. Section 5. Unraveling the Mysteries of the Solar Wind. The Parker Solar Probe, launched by NASA, is on a groundbreaking mission to study the Sun up close. This mission is providing us with invaluable data that is helping scientists understand the complex dynamics of our star. The Parker Solar Probe is sending back a treasure trove of data. This data is not just numbers and figures, it represents a new window into the Sun's behavior, offering us unprecedented insights that were previously out of reach. This data is giving us unprecedented insights into the Sun's behavior. We are now able to observe solar flares, sunspots, and other solar activities in greater detail than ever before. One of the key mysteries the probe is helping to unravel is the origin of the solar wind. Understanding where and how the solar wind originates is crucial for predicting space weather and protecting our technology. The solar wind is a constant stream of charged particles that flows from the Sun's corona. These particles travel through space and can have significant effects on planets including Earth. This wind can reach speeds of over 1 million miles per hour. Such high speeds are astonishing and raise questions about the mechanisms behind this acceleration. But how is this wind generated? What processes within the Sun are responsible for creating and propelling these particles into space? What accelerates these particles to such high speeds? Scientists are investigating various theories including magnetic reconnection and wave-particle interactions. The probe's measurements are suggesting that the solar wind is not a steady stream, as previously thought. Instead, it exhibits a complex, turbulent nature. Instead, it's more like a turbulent river, with bursts of high-speed particles interspersed with calmer regions. This turbulence could be key to understanding the solar wind's behavior. The probe has also detected strange switchbacks in the magnetic field lines emanating from the Sun. These switchbacks are sudden, sharp changes in the direction of the magnetic field. These switchbacks are like sudden U-turns in the magnetic field. They are a surprising discovery and could play a significant role in the dynamics of the solar wind. They could be responsible for accelerating the solar wind particles to their high speeds. As the Parker Solar Probe continues its mission, we can expect even more groundbreaking discoveries that will deepen our understanding of the Sun and its influence on the solar system. Riding the waves of energy, understanding solar flares. The Sun is not always a calm and steady neighbor. It can unleash sudden and violent bursts of energy, known as solar flares. These flares are like giant explosions on the Sun's surface. They release vast amounts of energy in the form of radiation and charged particles. Solar flares can be incredibly disruptive. They can interfere with radio communications, damage satellites, and even cause power outages on Earth. Understanding how solar flares are generated and how to predict them is crucial for protecting our technological infrastructure. The Parker Solar Probe is providing us with a front-row seat to study these solar flares. By flying close to the Sun, the probe can measure the particles and radiation released during these events. These measurements are helping scientists understand the mechanisms that trigger solar flares and improve our ability to predict them. A glimpse into the heart of the solar system. The Parker Solar Probe is not just about studying the Sun, it's also providing us with a glimpse into the heart of our solar system. The probe's instruments are measuring the properties of the interplanetary dust. This dust is made up of tiny particles. They are remnants from the formation of the solar system. By studying this dust, scientists can learn about the conditions that existed billions of years ago when the planets were forming. It's like finding cosmic breadcrumbs that tell us the story of our solar system's birth. The probe is also observing the zodiacal light. This faint glow is caused by sunlight reflecting off the dust particles scattered throughout the inner solar system. By studying the zodiacal light, scientists can learn about the distribution and composition of this dust. The journey continues. Future flybys. The Parker Solar Probe's mission is far from over. The probe will continue to orbit the Sun, making multiple close approaches over the next few years. Each flyby will bring the probe closer to the Sun. With each close approach, the probe will experience more extreme conditions. This will allow it to gather even more detailed data about the Sun's atmosphere and its behavior. This data will help scientists refine their models of the Sun and its influence on the solar system. The Parker Solar Probe is a testament to the power of human ingenuity and our relentless pursuit of knowledge. It's a mission that's pushing the boundaries of space exploration and revealing the secrets of our nearest star. Inspiring future generations. The Parker Solar Probe is more than just a scientific mission. It's an inspiration to us all. This daring mission is a testament to the human spirit of exploration and our desire to understand the universe around us. The discoveries made by the Parker Solar Probe will inspire future generations of scientists and engineers. It will spark their imaginations and encourage them to pursue careers in STEM fields. The probe is a reminder that there are still many mysteries out there waiting to be unlocked. It's a call to action for all of us to never stop exploring, to never stop asking questions, and to never stop pushing the boundaries of what's possible.